Okay, good day class. Alright, so okay, last lesson we have studied all the substitution, right? All type of substitution that we can use, okay, to solve or to find the answer for integrand, right? So today we are going to see 3.3.2b, alright, which is formulae derived from integration by substitution. By using this substitute method, actually we can integrate some common formula that we can apply directly. Alright, so here we have 6. 1, 2, 3, 4, 5, 6. Okay, first one, integrate ax plus b to the power of n. Then you can directly copy whatever the base, 2x plus b. Then index plus 1 over new index. Okay, just don't forget the a. The a come from here. Right? So this formula only apply for linear, means inside the bracket is linear. Okay, no square, no others. Okay, so we can direct apply this formula. Okay, second one is integrate 1 over ax plus b. Alright, remember this one we have just used before. So today we are going to see how we get this formula. Okay, so the answer is ln fx plus c. Okay, and the fourth one is if we have the integrand which is in the form e to the power of fx multiplied with the f prime x, then the answer is e to the power of fx plus c. Alright, the fifth one. Okay, so the fifth one is when e to the power of ax plus b. So this is actually also this is just for linear. The power is linear, ax plus b. It's different compared to this one. This one fx means it can be any function in x, linear or non-linear. Alright, then but the integrand must have f prime x at the side lah. Whereas this one e to the power of ax plus b only. It's only special for linear ax plus b. Okay, so if this happens, then it will be e ax plus b also, or e ax plus b and 1 over a. Again, this a come from here. Alright, and the number 6 is for cos, sine, tangent, secant square. Alright, so if you have cos ax plus b, then integrate cos, you get sine, right? Sine ax plus b, but 1 over a. Alright, here, the a come from here. Remember, the last lesson we have discussed, to integrate sine, cos, and secant square, we only can integrate ax plus b, cos or sine ax plus b. We cannot integrate cos square, cot cube, sine square, sine cube, all this cannot. Alright, we have to use substitution, then only can solve. Okay, alright, so now we are going to see how we can get this 6 formula. Alright, some are in your textbook. So the first 3 are in your textbook. So you can now open your textbook. Alright, page 96. Alright, open your textbook, page 96. Okay, so this is the first, let's see how we can get the first formula. So consider we are going to integrate ax plus b to the power of n. So remember, this formula inside the bracket only linear, So we use substitution, u equals ax plus b. So this is a normal step, as I say, as I explained to you all, this is a normal step, but normally we write like this, right? Differentiate left hand side with respect to u, differentiate right hand side with respect to x. Differentiate ax, you get a lah. Differentiate b, constant 0 lah. So it's a dx. Therefore, dx is a shift here, 1 over a du. Okay, now we sub in. See, integrate ax plus b power n. So ax plus b is u ma. So u power n multiply dx is 1 over a du, right? So 1 over a again is a coefficient, it's a constant, so we can move outside. And integrate un. So integrate un du ma, very simple. So index plus 1, or this one some mistake here. It should be in n plus 1, not here. So u to the power of n plus 1, index plus 1 over new index. Don't forget your a. This is where this a come from lah. Alright, then we sub back. Sub back the u. Alright, so this is the actual step, the actual substitution step to get this. So in exam, if the question never say anything, just say you are given 2 marks only for a question, and you are asking to integrate something like this, you can straight away apply formula. Okay, no need to show all this step. All right, so this is the first formula, how we get it. All right, second formula. So in your textbook, there are some examples lah, or you can study yourself, you see. We will discuss one lah. This one lah, okay. Integrate 2 minus 1 over 3x to the power of 7. So copy 2 minus 1 over 3x. So index plus 1. Or 8 lah, over new index. Okay, and don't forget your a. So your a means a is the coefficient in front of x. So coefficient in front of x is negative 1/3. Alright, so this is the answer. Okay, so we see the next formula. Oh, this one also some, okay. Alright, so same. We are using the same substitution. So remember this formula where especially the power is n equals negative 1. Alright, if n not equals negative 1, you just use the previous one, this one. Okay, if the power of n is negative 1, then you have to follow this formula. Okay, so same. Inside the bracket is ax plus b, so we use let u equals this one. Then differentiate them. Alright, with respect to u and with respect to x. So dx will be 1 over a du. Now we sub in. So when we sub in, this one will be 1 over u. Dx is 1 over a du. Alright, so 1 over is a coefficient we can put outside. Then we integrate 1 over u. du. So what integrate 1 over u is ln u, right? So this is where the 1 over a come from. Okay, so therefore when you integrate 1 over ax plus b dx, so you just write 1 over a, whatever in front of x, then ln of your fx. Okay, this is the second formula that derived from the method of substitution. Okay, the third one. Okay, the third one. So the third one I explain separately lah, so that you can clearer. Alright, so integrate and integrand, which is in this form, f prime x over fx. Remember, actually we used this formula before in the previous lesson. Okay, now we are going to see why we do that. Don't confuse with this formula. Remember, we have this formula. This formula then is just fx n plus 1 over n plus 1 plus c. Remember, this formula comes from the concept of integration is the inverse of differentiation. Whereas this formula is like this. Okay, and the fx no power. Can see, fx no power, just fx. Alright, this is the difference. Okay, how we get this? Alright, before we go to the step, we don't see here lah. We see here, easier to see. Okay, I want to explain a little bit the concept of implicit function. So they're easier. This one is not related to what we are going to do, but just the concept. I want you to understand the concept of implicit function. You see, remember last time we differentiate y squared dx with respect to x. So when we want to differentiate something with respect to x, suppose here must be x, right? But now it's y. Remember, it's y. So we still differentiate as usual. So differentiate y squared, I get 2y. And we write dy dx here. Remember this? Okay, because later we are going to apply this concept, alright? Okay, we see. Now we start like this. Consider a function ln u, where u is a function of x. Alright, u is a function of x means like this. Okay, so let's say u is a function in x. So let's say u equals fx. So when I differentiate u with respect to x, du dx, so I get f prime x, correct? Alright, then now I'm going to differentiate ln u with respect to x. Remember differentiate ln? If you differentiate ln x, you get 1 over x ma. So when you differentiate ln u, you get 1 over u lah. Then again, you see, we differentiate ln u with respect to x. Your variable is x. Suppose here is x, but there is no x here. But yet we differentiate as usual, but we write du dx here. Remember? Same concept like this one. This is why just now I want to explain here first. Okay? So differentiate ln u is 1 over u du dx. Alright? And 1 over u multiplied du dx, I actually can write in this way. Same. Alright, same. Means 1 multiplied du dx. So I can write at the numerator and let the u at the denominator. Okay, we can write in this way, yeah? Alright, next, I put integration sign at both. I integrate both sides with respect to x. It's still the same thing, you see? I just integrate both sides with respect to x. Okay? Remember the concept, when we integrate dy dx with respect to x, we get back our y here, right? So same lah. When we differentiate ln u dx with respect to x, so I get back my ln u lah. This is just like your y here. Okay? So differentiate d ln u dx, you get back your ln u. Of course lah, plus c lah. Alright? And here, what is du dx? Here, du dx is f prime x. And what is u? U is fx. Okay? Alright, so this is how we get this formula. Alright, therefore, ln u, what is u? U is fx ma. Therefore, this formula appeared. Alright, integrate f prime x over fx with respect to x, you get ln fx plus c. It comes from here. Okay, so this is the third formula that we can derive from the method of substitution. Okay, okay, maybe we see one example. Alright, maybe we see one example. Yeah, so this one. Integrate 3x squared over x cubed minus 4. So the denominator is your fx. So when you differentiate, you get 3x squared. Right? So exactly same. So this is in the form f prime x over fx. Alright, so direct apply the formula. So the answer is ln fx, or fx is here, plus c. Okay? This is one of the example. Okay, so the first three you can find the proven in your textbook and also some examples. Alright, you can refer yourself. Okay, where else? For 4, 5, 6, so you see in your textbook, they just write like this. In your textbook, they just write like this. They just give you some other formula that derive from the method of substitution. They never show. So I will still show. I will show this 4, 5, and 6. Trigo are the same, so I just show one of it. Alright? Okay. Here. Okay. So this is the proven for another 3 more formula. Alright, so as I say just now, 1 through 3 in the textbook already lah. Okay, the fourth one. The fourth one is when the integrand is in this form, e power fx and multiplied with f prime x. Then the answer is just e fx plus c. Alright, so we are going to integrate this one, right? So you have to know which one is your u. So let fx equals to u. Alright, so differentiate left hand side with respect to x, you get f prime x dx. Differentiate right hand side with respect to u, so 1 du lah. Okay, now we can sub in. So e fx means eu lah. Cannot, e fx means eu lah. And f prime x dx is du ma. So f prime x, see that? F prime x dx is your du lah. F prime x dx is your du. Alright, so integrate u lah, plus c, and u is fx. It's just that simple. Okay, we just apply the step for the substitution only. Okay, the fifth one. So again, as I say, if the power for e is any function, then here must be f prime x, then only can use this formula. Okay, then this one, how about if the power is a linear function? Just special for linear function, ax plus b. Okay, so the formula is 1 over a, same like just now, 1 over a, e ax plus b plus c. Alright, so to prove this formula, same. First, let ax plus b equals u. So du, so differentiate ax, you get a. B, constant differentiate constant 0 lah, so a dx. Therefore, dx is 1 over a du. You see, we use this one few times already, right? Okay, now we sub in. So e ax plus b is eu lah. and dx is 1 over a du from here. Alright, so 1 over a is a constant mass, so can put outside. Alright, so integrate EU. Alright, so write back in x. Okay, not difficult, right? Okay, next. The number 6 formula. Okay? Trigger. Alright, I just explain sign lah. So for cos and secant square, same thing lah. Okay? Let's say I want to integrate sine ax plus b. So again, so you must be very careful with the formula. Okay? This is special for linear, ax plus b only. Other than linear, cannot. So the answer is negative 1 over a. 1 over a. So again, you see the coefficient for x, 1 over a. Because integrate sine is negative cos ma, so you get cos here lah. So ax plus b. Okay? So same as usual. So we know that ax plus b will be a u. Alright, so du, a, dx. So dx is 1 over a du. Okay, now we sub in. So sine, this is u. And dx is 1 over a du. Again, 1 over a is a coefficient, can put outside. Alright, integrate sine u, you get negative cos u plus c. So just rewrite back into the same, in terms of x. That's it. Alright? Okay, really not difficult. So the 7 and the 8 formulae for the cos and secant square, same lah, same concept. Or if you want, you can try yourself. Okay? Alright, now we will see some example in your textbook. Alright, so we will see exercise 3.5 in your textbook. Alright, so please open your textbook. Open your textbook, page 100, exercise 3.5. Okay, so question 1. Okay, maybe I put here. Question 1. Find the following integral using this formula, the first formula. Alright, the first formula. So, I'm going to discuss 1D. Alright, 1D. So, you're asking to integrate 1 over 4th root. Okay, 4th root, not 4 multiplier. It's a 4th root, 3 plus 5x dx. Remember we said we want to apply formula. We don't have to go through all this step. Alright. So first thing, we rewrite it in the proper way. Oh, okay. I forgot. It's negative 1 over 4. Okay, 4th root means power 1 over 4 lah. But it's at the denominator ma, so we'll move up negative 1 over 4 lah. And inside is linear, right? Ax plus b. This is your a. Okay, this is your a. It's in the form ax plus b. So, direct formula. Copy whatever in the bracket. Index plus 1. So, negative 1 over 4 plus 1. 3 over 4. Oh, sorry, it's a mistake here. 3 over 4 over 3 over 4. Sorry, over 3 over 4. And don't forget, denominator multiplied with your a, which is 5. Alright, therefore, this is 15. 15 over 4. So when you move up, become 4 over 15. It's 1, 5. Okay, power 3 over 4. Okay, that's it. Just apply formula. Very simple. Just one thing. Inside must be linear. Okay, then you only can apply this formula. Alright, next. Second question, I'm going to discuss E. Okay, question 1E is like this. Integrate square root 1 minus x plus 1 over square root 1 minus x minus 1 over bracket 1 minus x and square. Dx. Alright, so first step, we write everything in linear form because I see that in the bracket, all are linear. All linear, ax plus b. Okay, but your a is negative 1, don't forget. Now your a is negative 1. So I write it in this way. So square root means power half. 1 over square root means power negative half. So this one move up, power negative 2. Now you can integrate by using the formula already. This is the formula. So index plus 1, so 3 over 2. Over 3 over 2, don't forget your a. So your a is negative 1. Alright, this one also. Index plus 1, over new index, again, multiply your a. Your a is negative 1. This one also, negative 2, index plus 1, negative 1. So over the new index, and this negative 1 is a. All right. Okay, so after that, just write it in the proper way. So this is negative 3 over 2. So when shift up, negative 2 over 3. This one negative half. When shift up, negative 2. Become negative 2. At first it's plus, become negative 2 lah. This one negative, negative become positive. So still negative. Power negative 1, I shift back to the new denominator lah. Alright? You can just let your answer in this form. If you think you want to factorize them, also can lah. But I don't think so lah. Just let it in this way. Alright? Okay? So this is the question for the first formula. Okay, now we are going to see second question 2. So question 2 is, you are asking to use this formula. E to the power of ax plus b. The answer is 1 over e ax plus b. Use this formula. Okay? This is very simple. So I think this one, I only discuss 2 questions. Alright? Okay, I discuss b first. Okay, I discuss b first. So this is the question. So first step, of course, you have to multiply in. So ex multiply e2x, e3x. Ex multiply e3x, e4x. Now this is in the form ax plus b already. Means your b is 0 lah. Okay? So multiply e3x, but 1 over a. Your a is 3. Alright? And integrate e4x also, but 1 over a. Your a is 4. Alright? Then plus c. That's it. Okay? Next. Alright? 2a. I go to question 2a. Alright? So you're asking to integrate e to the power of 2 minus 5x. So again, very simple. E to the power of 2 minus 5x. And now your a is negative 5. Your a is negative 5. So negative 1 over 5 lah. Or 1 over negative 5 lah. Okay? It's just that simple. Okay? Alright, next. Question 3. Okay, so question 3, you are asking to apply this formula. Yeah, where the integrand is in the form f prime x fx. So what you need to do is you have to determine what is your fx before you can continue. Alright? Okay, so question 3. Question 3. Okay. So I start with 3D. Alright? 3D. You're asking to integrate x plus 1 over x squared plus 2x plus 5. Normally the denominator is your fx lah. Then you try to differentiate. Find your f prime x. So differentiate y squared 2x. Differentiate x squared 2x. Differentiate 2x 2. Differentiate constant 0. So your f prime x supposed 2x plus 2. But now I only have x plus 1. I need 2x plus 2. So what is left? Yeah, I need a 2 here, right? I need a 2 in front. Then see. Yes, I need a 2 here. So that become 2x plus 2. Then only it is f prime x, fx. Right? But again, we cannot just add 1, 2 here, right? So we multiply half outside. So it still remain the same. It's multiplied 1. We didn't change the value. Can I? Okay, now it's in the form f prime x, fx. Therefore, straight away apply formula. The half is here. So integrate this one is ln x squared plus 2x plus 5 plus c. That's it. You just need to recognize this. Alright, check whether it is in the form f prime x, fx. Alright, okay, next example. This one. 1 over x ln x. It seems like not like this one, right? So you have to think. Your denominator suppose something that you can differentiate, right? Because it is your fx ma. It's suppose something you can differentiate. So x and ln x, of course we can differentiate ln x, right? Okay. So we choose ln x as our fx. Okay, ln x as our fx. So f prime x is 1 over x. And you see 1 over x here, right? Yeah. So I rearrange it first in the form that you can see easily. So 1 over x ln x, we actually can write in this way. Means 1 over x multiplied with 1 over ln x. 1 over x multiplied with 1 over ln x. So when multiplied, the number we can put at the denominator. We can put in the, okay, maybe so it is actually same like this. 1 over x ln x, I can write in this way. 1 over x multiplied 1 over ln x. And when a number multiplied with a fraction, we normally multiply it into the numerator. Also 1 over x multiplied 1. So we can really write like this. So I hope you understand this. Okay. Now it's in the form f prime x, fx already. Alright, f prime x, fx. Therefore, the answer is ln fx. This is your fx. So have two ln there lah. Don't confuse lah. Okay, ln fx. Your fx is another ln x. Okay, plus c. Right? Okay, one more example. C. No, sorry. This is question 4. Others, you do yourself. Okay, others, please do yourself. Okay, now we are going to question 4. Oh, hold on. Okay. Question 4. This one. Use this formula. Question 4 want you to use this formula. Again, also you have to know what is your fx and see whether at the side you get f prime x or not. Alright? Okay, so question 4, I'm going to discuss C. Alright? E power square root x over square root x dx. So let's say if e power square root x, so definitely your fx is square root x. Your fx is square root x. Square root x is x power half. So differentiate, index in front, index minus 1. So half x power negative half. Okay, so I can write in this way, 1 over 2 square root x. Because negative I write down. So this is my f prime x. Okay, how we can write this one in this form? This is how we write. Right? So I can separate e power square root x over square root x. I write it in this way. You don't see the red color first. You don't see this one first. You don't see this one first. Okay. So this integrand I can write in this way. Same. Alright. 1 over square root x e power square root x. Okay. So this is your EFX. And here is already like your f prime x. Right? Your f prime x, but I need a 2 here. I need a 2 here. Then only f prime x, right? Therefore, I add a 2 here. But again, we cannot suddenly add 2 here, right? So I multiply 2. So 2 and 2 simplified, I still get my 1. Don't confuse with this. You see? This one, I add 2 at the numerator. So outside is half. But this one, I actually multiply half lah. So 2 outside lah. Alright, now this is in the form f prime x EFX. Okay, so 2 copy. So this is already in the form f prime x EFX. So the answer is just EFX, then plus C. Okay? Not difficult lah for this part. Okay. Next. Yeah, one more. Question 5. Question 5. Here. Okay, see? You're asking to write down this one. Integrate this one by using formula. This one very simple. Alright? Then you're asking to show this one. 1 over 1 plus EX, same as this. Show this one first. Then find this. It's different. It's different. Okay? Alright. So we show the first one. This one very simple. Okay, so the first one. Yep. Integrate this. So this is very clear. This is your fx. This is your fx. So differentiate 1, you get 0. Differentiate ex, you get ex. So this is your f prime x. So this is in the form f prime x fx. Okay, it's not like formula number 4. This is in the form f prime x fx. So if it is already in the form f prime x fx, the answer is ln fx plus c. Alright? Okay. Now next, they want us to show this one. I should open. Same like this. They want us to show this one become this. So very simple. There must be a 1 here. So to get 1, the numerator also must have 1 plus ex, right? 1 plus ex over 1 plus ex, 1 lah. So I add ex here. But I cannot suddenly add EX here, right? So I minus it out. Okay, I minus it out. So it's still the same, right? So next, this one become 1. And this one is this term. Shown. Don't confuse. I know that maybe you remember, teacher like say something cannot add variable X. That one is for this condition. That one is for this situation. This one you cannot multiply X. And multiply 1 over X outside, cannot. But this one different, I'm not multiply, I add EX, then I minus it. So still remain the same, right? Yeah, I didn't change the value, right? This one different. This one because it's in the integration sign. This is in the integration sign. Or you cannot say, then I multiply X and multiply 1 over X. Then also cancel what? Cannot. Because you know that actually variable cannot take outside, right? Correct? Variable cannot put outside. Only number can put outside, ma. So don't confuse these two concepts. Alright? So already proved. So next, the question wants us to integrate this. So very simple, because you're already asking to show this one. So integrate this, same as integrate this one. Same. Alright? So next step, integrate 1, you get X. Integrate this, the first part have done. So just copy only. Okay? Alright, so today is like quite simple. Quite simple. So this is all we want to discuss for today's lesson. Okay, as usual, homework. So please complete all this homework. Alright? And send to your folder before 9 p.m. tonight lah. Before 9 p.m. tonight lah. Send this one to your folder. Okay? And quiz. Only one quiz, which is in your notes. Here, your notes. This one. I want you to do this quiz. Alright, so after the lesson, I want this one by 4 p.m. Alright, by 4 p.m. everyone pass up this one first. Then this one 9 p.m. Alright? Okay, thank you class.